So in this short video, I'll go over maybe how to get started on this week one problem. I'm gonna ask you to be creative and come up with a sketch of a graph, okay, a piecewise function. So I'll do one example, but I want you to come up with your own. So let me see, let me just start from the scratch, okay? I'll go ahead and share my screen with you. And Aveen gave me a piece of graph paper, but I think so that I can show you what you are doing here, I'm gonna just go ahead and start from scratch. Like I don't even have a graph paper right now, but I'm just gonna go and Google one right now, okay? So here is me. I'll open up a Chrome. Oh, what's all this? I'll go ahead and go to just a graph paper, just a graph paper. But if you have one already, use that one. Um, and I like to have one that has like the numbers already. I'll just go ahead and Google like graph grid. If you don't have one, you can just, oh, this looks good. I'll go ahead and use this one. I'll copy this image, and I'll just go to a blank sheet of paper and start from there, okay? Go ahead and just put that graph paper right here. Why isn't it working? Let me try again. Oh, here it is. There's a graph paper that I just got off Google. So what are we doing for this assignment? I want you to create a sketch, okay? Like just come up with something, come up with something, not like that, but it has to have certain conditions, okay? So first, I want you to have at least 3 different pieces of graph. Could be linear, constant, could be absolute value, quadratic, or a rational piece, okay? I'm gonna go ahead and just sketch one, okay? I'll come up with the horizontal. Hold on. Let me adjust my pen. I'll come up with like that's too thick. Sorry. I'll just have like a line right here, and I'll have like an open circle right here. So that's the constant function. How about I have another one this time, an absolute value function. I'm just free drawing, you guys. Like, gonna go up here, and then it's gonna just go down. That's my absolute value function. And that's just going to go down to like this point. I'll put an open circle. What else did they say? They said we can have a quadratic, but it's hard for me to draw a quadratic. You can, just free drawing. What other function types? Linear, rational piece. I may do something like this. I may do something like start from here. Yeah, I'll start here, and I'll just go up, and I'll make it look like it's approaching some kind of horizontal asymptote. I don't know, I sketched something. I have 3 pieces. I have a constant function and absolute value. This absolute value could be seen as 2 linear functions. And I try to make the third one looking like a rational function, but listen, you guys, I'm not requiring you to write equation of these functions. Just draw something for me. And if you have a straight line, some, diagonal lines and maybe a curve, that will do. That will just do, okay? But let's see. I have 3 pieces, so I'm good there. But it says a point where the limit does not exist because the left-hand limit and the right-hand limit does not match. I think I have that here. I have an open circle up here. I have a closed circle here. So the left-hand limit and the right-hand limit is different at x equals -3. You see, to the left, to the left of -3, it looks like the function value is going to be 3 all the time. But to the right of -3, it's going down to -2. So I have that point. The limit does not exist at x equals -3 because the left piece and the right piece are not meeting at the same place. So I have that second condition. But later on, I'm going to have to go back and write all these down, okay, using limit notation. What's the second condition, or the third point? A point where the limit exists, but the function value is undefined. Now that's a tricky one. So limit exists, but the function value is undefined. Now listen, to make a function to be undefined, we need to have an open circle. So I'm going to have to be creative here. I'm going to have to add an open circle somewhere. Okay. All right, hold on one second. How about, I like this piece a lot, but I'm going to go ahead and erase this real quick, okay? I'll go ahead and like make this graph to go up like this. And then I'll add an open circle right here. And then I'll just keep on going to the right. Okay. Keep on going to the right. Ooh, see? This function is not defined at x equals 3 because I have an open circle here. I don't have a point, okay? I don't have a closed circle at x equals 3. But the limit exists because to the left and to the right, it looks like they were both going to -1. So for the third point right here, you had to add an open circle in the middle of a continuous graph. It's like a hole in a graph. Okay, but we'll go back and like use limit notation to write all these. All right, what's the fourth one? A point where the limit exists, but it does not match the defined function value. Now that's so tricky. So what we need to make is we need to have a limit, but the function value is somewhere else. I think we've seen an example like that before. Okay, take a look on one of the examples that we did. All right, let me find it. Oh, right here. You see, for this picture right here, the limit is 4, right? Because to the left and to the right is approaching 4. It's going to that open circle. To the left and right, they continue. They're really trying hard to get there. But look, the function value is down here. The function value is -1. So that's what we need to sketch. We need to have a piece of a graph, like a part of a graph that has an open circle on its curve, but a closed circle is somewhere else. Okay, so let's go back and be super creative. Okay, I'm back over here. I can't just add a point here because if I do that, then now I have a function value at x equals 3. So let me see. I'll break another point. I will break another point. I'll go ahead and break this graph, okay? And I'll do it like this. So it's going up. It's going up. Oh, you know what? I'll break the second piece. Hold on a second, you guys. I'll break this guy. I'll say I'm going up, but I have an open circle right here. Let's keep going up and it's going to meet there. So the limit at x equals 1 is going to be -3 because to the left and to the right, do you see how they're trying to meet at -3? But I'm going to put a function value, a closed circle somewhere completely random. I'm just going to put it right here. See, that meets the condition then. So the limit is down at -3, but the function value is up at +2. So you need to have a graph that has some of these things, and if I can just check all of them, then that should be good. Now lastly, I just need to use the limit notations to talk about number 2, number 3, and number 4. Okay, so for number 2, okay, I can say, because number 2 was about limit does not exist because the left-hand limit and the right-hand limit does not exist. I can say limit, and if I name my function S for Sue, S of x as x approaches -3 from the left is equal to 3, okay? And limit as S of x approaches -3 from the right is -2. Okay, I can tell them because left-hand limit does not match the right-hand limit, what I have to tell them is the general limit as x approaches -3 does not exist. So I wrote one sentence talking about how this part, hold on a second, this part, we have two different one-sided limit. Left limit does not match the right-hand limit, therefore the limit at -3 does not exist. So that's good. Okay, that was tricky. All right, number 3. Let's explain number 3 using all these limit notations. 3 was, forgot what it was. 3 was a point where the limit exists, but the function value is undefined. Okay, so that's this point right here. Okay? I can say that limit of s of x as x approaches 3 is equal to -1. But I can tell them, but s of 3 is undefined. Okay? Because we have an open circle at 3, -1. So from the left and from the right, they're both approaching -1. But we don't have a closed circle on this x equals 3. So the function value is undefined. So that was number 3. All right, let's do the very last part, number 4. So everyone's answer will be different. If you submit something exactly the same as mine, don't do that. You do your own graph, okay? A point where the limit exists, but it does not match the defined function value. Oh, that was the last one. So that was this one right here, the red dot. So I have to now talk about this red dot. Okay? I'm out of room, so I'll write it here, okay? I can tell them that the limit of s of x is approaching, what number? 1 is equal to -3. Why? Because to the right and to the left, they're trying to go to -3. But s of 1 is up at 2. Now I went over this super quick. So if you're watching this before you practice graphical limits, this is going to be completely confusing, right? But if you truly understand graphical limits, one-sided limits, these limit notations, you should be able to do a good job on this assessment, okay? I want you to try, and if you get stuck, I'll work with you, but this is like an end product that I want you to be able to do when you completely understand section 1.1. So I'll go ahead and post this video too, but I look forward to looking at your creative graph for your week 1 problem.